Now we're going to continue on in Unit 1, and we're going to discuss density. We had done a density problem when we were working conversions a few pages back. And there I told you that density was a measured number and we have to consider significant figures. So now, hopefully, it will make sense more of why we have to consider density for significant figures. Now, density relates mass to volume, and this is something that you might not know by the name density. But let's say I had two boxes. I asked you to carry a box. I said, I don't care which one you carry, I just cannot carry both at the same time. And I told you that one box contained heavy chemistry books, and the other box was filled with feathers. And you said, really? You don't care which one I carry? No, not at all. Well, it turns out you might have a bad back, so you picked the one with the feathers. Now, these boxes were equal size, so they had the same volume. But what differed was their contents. So the mass of the chemistry textbooks was a lot more than the mass of the feathers. So you choosing the feathers, it has to do with density. And so smart you for picking the feathers. You know, you're not going to expend as much energy, and hopefully it doesn't hurt your back as much. So density relates mass to volume. And like I said, you use this every day. This concept, it just might not have that title in your brain. So density is mass divided by volume. And this is an equation that you need to know. I won't give it to you. But the more you work with density, the more straightforward this will become. So mass, the units can be grams or kilograms. Volume, the units can be milliliters, liters, or cubic centimeters. The units that you end up with after you've calculated density would be grams per milliliter, and I really prefer to write it like this, grams per milliliter, or grams per cubic centimeter. And a lot of times you'll see grams per milliliter used for liquids and grams per cubic centimeter used for solids. So both of these, the mass and the volume, are measured numbers. So because these are measured numbers, you have to use significant figures with density. It's a measured number. So mass is measured, volume is measured. And if you go on to your other chemistry classes, whether it's Principles of Chemistry or Chem 124 General Chemistry, you will find that there probably will be a lab or two or three on how to calculate density. And unfortunately, significant figures can be deducted a lot in those labs. So pay attention to that when you get there. Okay, so I have some substances and I've given the density. So water, just your normal tap water, like room temperature, has a density of 1 gram per milliliter. Ice has a density of 0.916 milliliters, so it's less dense than water. That's why ice floats in water. Now, if you notice, alcohol has a density of 0.78, so it's less than water, and it's also less than ice. So if alcohol and water didn't mix, they do mix, the alcohol would be the bottom layer, and the water would be the bottom layer, and the alcohol would be the top layer because the alcohol is less dense. But that's not the case because water and alcohol mix. But what you can see is with ice. So ice is more dense than alcohol. So if you have neat alcohol, let's just say neat whiskey or neat vodka, and you put an ice cube in that vodka or whiskey, the ice cube, instead of floating, will sink. So you can impress your friends with this at some point and say, ooh, I know, this has to do with density. Let's see, body fat is less dense than water, so body fat would float. I went I was helping my friend one time. She wanted to go shopping for a hot tub. And so we went to this hot tub. We went to this hot tub store, and we went, they had hot tubs all over the floor, and they were filled with water, so you're supposed to try them out. And the sales guy was really trying to work my friend over because he wanted to make a sale. So he's like, this particular model is better for women because women are more buoyant. And I just kind of, taking in what he was saying and trying to control my facial expressions. But what he was saying, that women are more buoyant. Women have a higher body fat percentage, so they're more likely to float in this water. So they have specially designed seats. Now she did end up getting a hot tub, and she really enjoyed it. So, but I always think that's funny the way he put it, more buoyant. Now, when you're in the lab, it's very practical to use density when measuring out liquids. If you don't want to measure out 1.50 grams of ethanol, because you would use a scale for that, you could use a graduated cylinder instead. So that measures volume. So a lot of times, what you're going to be given is 2 of the 3 values in this density equation. And I'm going to show you this density triangle. And I want you to use it with caution if you choose to use it. When I first started teaching principles of chemistry, I didn't teach it with a density triangle. And one of my students had worked with a tutor, and she said, oh, this density triangle is great. I really understand it now. It makes it so much easier. I don't have to worry about unit cancellation. Well, she used the density triangle, but she had the triangle filled out incorrectly. So she would have gotten the correct answers had she had it filled out correctly. So that's what I always warn students. Density is mass over volume. Where do you go to renew your driver's license? The DMV, okay? So she had one of these flips, and all her answers were wrong, which was a shame. But the way you work this density triangle is whatever you're looking for, you cover up. So if you don't have mass, you cover that up and you say mass equals, and then if these 2 are next to each other, density times volume. Okay, then, let's say you're looking for density, so it's going to be mass divided by volume. And then if you're looking for volume, volume is going to be mass over density. So this question, how many milliliters are there in 1.50 grams? So one of the challenging aspects of density problems is not actually executing the density triangle. It's figuring out what they're asking for. So what is milliliters? So you're supposed to find how many milliliters. And milliliters is a unit. It's not of density, because density would have grams per milliliter or grams per cubic centimeter. It's not mass, because that would be grams. It's volume. So you're given volume. You're asked to find volume. You're given mass, and you're given density. So practice labeling your density problems like this, because I have a lot of students like, I don't even know what I'm looking for. I can't even use the triangle because I don't know what I'm looking for. So be sure to label each one of these when you're given and find. Okay, so we're looking for volume. So our equation is going to be volume equals mass over density. So I'll put 1.50 grams, 0.789 grams per milliliter. And a lot of students, when they get to this point, they're like, I don't know how these units cancel. Remember that when you divide by a fraction, it's the same as multiplying by the reciprocal. So you're really multiplying. So the reciprocal means I flip this. So I have milliliters here, grams here. grams cancel out, and I get milliliters. So to enter this into my calculator, 1.50 divided by 0.789, I end up with 1.901 milliliters. Okay, so I have 3 sig figs here, 3 sig figs here. So we get 1.90 milliliters. Okay, so this was using the density triangle method. The other way that you can use this is just with straight out conversion. So if you do that, this is going to be your starting quantity, 1.50 grams. And this is going to be your conversion factor. So 1.50 grams over 1, 0.789 grams over 1 milliliter. So 1.5 divided by 0.789, get the same answer. So I'm not particular about how you work the problem. You can use the density triangle or you can use conversions. I just care that you get the correct answer with the correct units and understand how to work those problems. So on the next page, there are practice problems. And I want you to hit pause and work through these first 3 problems. Try. Be sure you start off with given, find. Be sure to label what is mass, what is volume, what is density. So do that for all of these because it is such an important skill when working these density problems. In my opinion, and usually students will agree with this, density problems aren't the hard ones. It's usually the conversion problems that are the hard ones. You can make density ones more challenging if you don't know how to label mass, volume, or density. So be sure to practice these, and then when you come back, we'll go over those. Okay, for question 1, you're given 36.4 grams, which is mass, and you're given 45.6 milliliters, which is volume. So you're asked to solve for density. Density equals mass over volume. So you divide 36.4 grams by 45.6 milliliters, and you get 0.798 grams per milliliter. Okay, so significant figure-wise, you have 3 sig figs here, 3 sig figs here. All right, for the next question, you're given 18.0 milliliters, which is volume, and then you're given 0.67 grams per milliliter, which is density. You're asked to find the mass. So mass equals density times volume. So it's 0.67 grams over 1 milliliter times 18 milliliters. Your units cancel out, and you get 12 grams. You have to factor in both of these numbers for sig figs. So you end up with 2 sig figs. Your answer cannot have more than 2 sig figs. Okay, so for the last question, milk has a density of 1.03 grams per milliliter. How many milliliters are in 25 milligrams of milk? So you're given density, you're given mass, you're asked to find the volume. So volume equals mass over density. One thing I will point out in this problem is if you notice, this is milligrams. This is grams. They are not going to cancel out. If you just plug them into the equation, it's not going to magically convert milligrams to grams. So I recommend that you convert milligrams to grams ahead of time. Now remember the base unit, it goes deci, centi, milli, 1, 2, 3. So we're going to go from milli to the base unit, that's 3 to the left. So 1, 2, 3. So it would be 0.025. Go grams. So I get 0.025 grams divided by 1.03 grams per milliliter. We're going to take this fraction, not this number, but the fraction, and flip it. Multiply by the reciprocal, so milliliters will be on top, grams will be on the bottom, grams will cancel out, you'll get units of milliliters. So 0.025 divided by 1.03, end up with 0.024 milliliters. Let's see that, 0.024 milliliters. Now, you have 2 sig figs, 3 sig figs. Your answer cannot have more than 2 sig figs. Okay. So I highly recommend that you label what each quantity that's given is and what you're trying to find. It makes it so much easier. So we're going to take a little break from working problems and we're going to go over some definitions. And a lot of times students struggle with how to study these definitions. Study, however, works best for you. I know each student has a different way. I have some students who can read the textbook and learn so much from the textbook. I have other students who cannot read the textbook, but I do encourage you all to open your textbook and read and go over it. So when you get to these definitions, you probably are asking yourself, how is she going to test us over this? How is she going to ask questions? Well, definitions, by their nature, lend themselves to true-false questions or multiple choice questions, or even matching questions. So be prepared for that possibility. A lot of students really benefit from making flashcards or from rewriting. I was not really a flashcard student. I would make flashcards, but then they just didn't click with me. So I would always rewrite. So like I would have a blank piece of paper and I would fill out these definitions again and again and again. So don't forget to study the definitions. I have a lot of students who are so concerned about the problems, especially the conversion problems or the density problems, that they forget that they have to do the definitions. So okay, so distinguish among the 3 states of matter: solid, liquids, and gases. So matter is anything that occupies space and has mass. Okay, atoms are the building blocks of matter. And molecules, or compounds, 2 or more atoms bonded together. So an example of that would be H2O. Okay, so there are states of matter: solid, liquid, and gas. So we have 2 solids, 2 types of solids. There's crystalline and amorphous. Okay, so crystalline, atoms, molecules, or compounds arranged in geometric patterns with order. So an example, salt, which is NaCl, or diamond. So I don't know if you have ever done this trick. You have a drink, let's say at a bar, and this glass keeps sticking to the napkin, and you kind of find it frustrating. Maybe some people like it. I don't know. Sometimes it can drive you nuts. So if you take some salt and you sprinkle it onto the napkin, and then you set your glass on top of that salt, the napkin will no longer stick to your drink. And the reason that is because if you ever have taken the time to look at a crystal of salt, it's this neat, ordered cube. So your drink is resting on the cubes of salt instead of getting stuck to so the napkin doesn't get stuck to the side of the condensation on your drink. So again, another way you can impress your friends with chemistry. Maybe you can convince them that chemistry is cool. It's not only for dorks, it's for cool people too. Hello. So, but salt is an example of a crystalline solid because it has that very fixed, rigid shape and organization, and it makes your napkin not stick to your drink. Okay, the other class of solids is when atoms, molecules, or compounds do not have order. Okay, so amorphous solids, examples would be like glass, rubber, and plastic. Okay, so examples of liquids, if you're drinking water, your sodas, a lot of examples of liquids, and then gas would be like air, helium, hydrogen. Okay, so let's go over the properties of solids, liquids, and gases. So, shape. Solids definitely have shape, so it's definite. Okay, liquids don't have shape. They take on the shape of the container. So, shape of container. And the gas is the same thing. It takes on the shape of the container. Okay, so solids definitely have volume. So they have volume. You can calculate that length times width times height, or you can do water displacement. Liquids have volume as well. You can measure them with a graduated cylinder. And a gas does not have volume. Okay, so the atomic or molecular motion for a solid is vibration about a fixed point. Liquid, the motion, they're free to move about relative to each other. And then the same thing applies for a gas. So, let's see. Okay, the molecular or atomic spacing for a solid is closest together. A liquid, closer together. And then a gas is far apart. So those atoms or molecules of gas don't want to have any interaction. So a solid is not compressible. You cannot squeeze it anymore. A liquid, not compressible, but a gas is. Okay, so this page is a good example of what you could put on a note card. So just all these definitions, or you could rewrite this page, print it off, and fill it out again to study for your exam. And then there are questions in your textbook covering these topics as well. Okay, so the next part of the next page is to classify matter according to its composition, elements, compounds, and mixtures. So matter can be divided into two classes: pure substances and mixtures. So a pure substance would be like one atom or one molecule. A mixture would be two or more atoms or molecules in varying proportions. So like salt, water. So that would be a mixture. Whereas over here you could just have water, pure water. So pure substances can be broken down into elements and then compounds. So elements can't be broken down any further. So an example would be silver, the element silver. Okay, compounds would be two or more elements in fixed, definite proportions. Example would be water. Water always has two hydrogens and one oxygen. Okay, so then mixtures can be broken down further to homogeneous or heterogeneous. So homogeneous would be consistent throughout. So peanut butter would be an example. And heterogeneous, I didn't say. This type of peanut butter would be creamy peanut butter. Heterogeneous would be different parts are visible. And that would be like crunchy peanut butter. Another example for homogeneous would be like a tomato soup, versus a heterogeneous mixture would be like chicken noodle soup. You definitely see the noodles, the chicken, the vegetables, the celery, the carrots, that type of stuff. Okay. So I want you to classify each type of matter as a pure substance or mixture. If it is a pure substance, classify it as an element or compound. If it is a mixture, classify it as homogeneous or homogeneous or heterogeneous. So use this flow chart. All right, mercury in a thermometer. These are what I want you to classify. So hit pause, to work through this, and then we'll go over the answers. Okay. So mercury in a thermometer would be classified as a pure element. Exhaled air, that is kind of unclear. I'd say exhaled air would be a mixture, and it would be homogeneous. Let me add another one. If I said something like exhaled CO2, then that would be a little clearer. So I would say pure compound. Okay, chicken noodle soup is going to be a mixture, heterogeneous, and then sugar would be pure compound. Okay, so kind of more, now we've been over some definitions of solids, liquids, and gases, elements, compounds, and mixtures. Now we're going to talk about changes and properties. Okay, so a physical property is something that a substance displays without changing composition. So an example would be appearance, state, and when I say state, I don't mean like Kansas, Missouri, Nebraska, Oklahoma, none of that. I mean solid, liquid, or gas. So a chemical property is what a substance displays only through changing composition. So, example would be reactivity. So how does it react with hydrogen gas? How does it react with an acid like HCl? So I want you to hit pause and work this problem. Classify each property as physical or chemical. Okay, so the explosiveness of hydrogen gas would be chemical. So I'll put C for chemical. The bronze color of copper would be physical. The shiny appearance of silver would be physical. The ability of dry ice to sublime, so that means to change from solid directly to vapor, that would be physical as well. So a physical change, kind of touched on this with physical properties, is matter changes appearance, but not composition. So example, CO2 solid to CO2 gas. So that would be a physical change. And this is actually dry ice. So you see this around Halloween, those fog machines, they use dry ice. And you can actually buy dry ice at some grocery stores. If you look usually at the front near the customer service counter, they have a cooler and it's dry ice. And some people use it to make like punches so you can get that carbonation. Okay, a chemical change would be matter changes composition. So an example would be rusting. So metal goes to, so a shiny metal goes to a red-brown oxidized state. All right, so I want you to hit pause and work through these descriptions. So classify each change as physical or chemical. Copper metal forming a blue solution when it is dropped into a colorless nitric acid. That would be chemical. A train flattening a penny placed on a railroad track. That would be physical. Ice melting into liquid water. That would be physical. A match igniting a firework. Okay. So the last part of this section is separating mixtures through physical changes. Okay, so with filtration, you're using a funnel, and then usually there's a piece of filter paper, kind of like coffee filter. Again, the coffee filter is a good example of that, how you keep the solid separate from the liquid. So you are separating a solid from a liquid. With distillation, you're taking a liquid mixture, you're heating it up. So usually there's a glass vessel, which contains the mixture. You're heating it up. It boils, so then it separates into a gas, which is pure. And then on the other side, you condense the gas, so you convert it back to a liquid, and it's pure. And there's a picture of this in your textbook. But usually in order to carry out a distillation, you have to have pretty specific glassware. And that with that glassware, you can accomplish this separation from liquid mixture to pure gas to pure liquid. So we will stop here for now. Review those definitions, review the problems on density. Make sure you're doing the assigned homework problems.